In 2002, the Oakland Athletics general manager Billy Beane pioneered a new approach to baseball. It became known as Moneyball. In short, he used data and analytics to identify undervalued players, and in doing this, his team set a new record for the greatest number of consecutive wins. The effect of Moneyball was so drastic that every other baseball team was forced to change for fear of being left behind. Needless to say, data analysis had completely revolutionized the sport. And naturally, other sports attempted to follow suit. And just like baseball, lots have successfully evolved. But football hasn't. And this isn't just because North America led the sports data revolution, or because football holds some traditional values opposed to the use of data. Instead, it's because of one key but underappreciated reality. Football is much, much harder to analyse than almost every other sport. Picture this. It's a game of cricket. There's a batter, a bowler, and some fielders. The bowler bowls the ball, and we freeze frame just as it's approaching the batter. Now consider the possible eventualities that might play out here. The batter could miss the ball. In this scenario, the ball could hit the stumps or miss the stumps. It could be caught by a fielder or the wicketkeeper, or missed entirely. The batter might hit the ball, it might be knocked down just a few feet away, or hit over the crowd for 6. To be frank, almost anything could happen, and if we tried to calculate all the various permutations, it would result in a very, very large number. And now we unfreeze. You see, in this scenario, the batter misses the ball, but the ball misses the wicket and is caught by the wicketkeeper, and then the game stops. Now imagine a football game. There's 22 players on the pitch, and the ball is with one of the goalkeepers at a goal kick. There is currently a pause in the action, but it's about to restart. The goalkeeper starts to pass the ball to one of their centre-backs, and again we freeze frame. Just the same as the cricket scenario, almost anything could happen here. The centre-back could successfully receive the ball, it could be intercepted by an opposition attacker, the pass could be misplaced and go out of bounds for a throw-in. There are more meaningful possible scenarios given the number of players in active play, but essentially the various permutations again result in a very, very large number. The key difference here is that in most of the possible eventualities in this scenario, the game is not then going to stop, like it did in the cricket example. Let's say that the centre-back did receive the pass successfully. That player is now faced with all of those permutations all over again, compounding the number of eventualities. Our very, very big number gets even bigger. And as the ball continues to be passed around or intercepted or whatever happens, the permutations quickly become incalculable. You see, this is the reason that football is so much harder to analyse. It is a continuous sport, as opposed to cricket and baseball, both of which would be better termed as discrete sports, or sports made up of brief, well-defined actions that have a clear beginning and end. In football, sequences of play don't have a set beginning or end. Where sports like basketball, for example, are divided into periods of possession that can last for a maximum of 24 seconds, in football, one pattern of play leads straight into another. And this is what makes the collection of data much trickier. And if not the collection of it, then certainly the use and interpretation of it. Christopher Clemens, the head analyst of Germany's 2014 World Cup winning national team, went as far as to say, "We're increasingly convinced that there's a lack of data that provides real information about the things that make you successful in football." So thinking about that, here's a spectrum of sports from the most discrete to the most continuous. Now, as we said, baseball and cricket appear towards the discrete end of the spectrum. You could argue that a sport like darts is one of the most discrete, particularly when you consider that there's no defending. 2 opponents take it in turns to do almost the same thing each time they step up to the board, while the least discrete element here is that as the players get towards a lower score, they need to hit different parts of the dartboard in order to win the game, meaning that it's not quite the same action every time. 10-pin bowling, on the other hand, might be the most discrete sport of all, due to the repetitive nature of each throw or each bowl. In theory, the perfect bowling game includes an exact replica of the same action throughout the entire game. And because the environment is exactly the same each time, tracking a player's strike percentage is a much more accurate means of determining either the quality of that player or meaningful changes a player should make to their game in order to improve the score. It would be the equivalent of a game of football just consisting of penalty kicks against an unchanging goalkeeper over and over again. Now, rugby might sit somewhere in the middle. Elements like penalty kicks and lineouts are relatively discrete though, and the limited outcomes of a crucial piece of gameplay like a scrum arguably stop it from being classified as more continuous. And in comparison, football is undoubtedly at the more continuous end. Even with the stop-start elements like a corner kick or a penalty, there are almost infinite outcomes that could occur the second the ball is put back into play, making it extremely hard to determine what data is useful. And just to be clear, we're talking specifically about the use of data to help determine how the game itself should be played. Numerous football teams have successfully developed and used sophisticated data models to advance their recruitment, for example, identifying bigger talents better suited to their team's style of play and often for under market value. But the success of this remains largely down to the fact that better footballers play better football. In terms of determining a style of play, data has had a more limited impact. But of course, this hasn't stopped analysts from trying. Perhaps the most famous example of a football dataset is called expected goals, a metric that quantifies the quality of a goal-scoring chance by estimating the probability of a shot resulting in a goal. But it's far from perfect, and it has to take into account a lengthy list of variables that simply don't exist in less continuous sports. And of course, football is by no means alone in this regard. Australian rules football is arguably more continuous, with constant substitutions and no offsides. And elements of ice hockey too, where substitutions are frequent and can happen during the play. These sports belie the attempts to simplify them. They simply cannot be captured as reliably through the use of data analysis alone. And so, while the data revolution will continue to optimize the sporting world, some sports, the continuous ones, will always be more immune than others.